Alright, you guys, so let's go ahead and take a look at part 2 here of the lesson 5.1 of parabola intro. So I do want to go ahead and talk about this here, guys. What you guys are seeing here, these graphs, this actually talks about intercepts, right? The types of intercepts we have here in our parabolas. So for example, if we're taking a look at this first graph here, I do have two parabolas, one's in green, one's in purple. And these types of parabolas are going to have two x-intercepts. And by two x-intercepts, once again, it's based on how many times the parabola actually crosses the x-axis. If we're taking a look, for example, here at the green one, it crosses it here and there, which means it has two x-intercepts. If I move on to the purple one, once again, it touches it in two different areas or two different spots. So it has two x-intercepts. So in a parabola, you could either have two x-intercepts, one x-intercept, or no x-intercepts at all. So this is what two x-intercepts looks like. If we take a look at this one here, one x-intercept, it's just telling us that the parabola is just going to be crossing the x-axis once. So taking a look at this first one, the orange parabola here, it crosses the x-axis at one point. And then we have this other parabola, which is the one in pink, upward or downward. It only crosses the x-axis at one point. So this is what one x-intercept would look like. It's just crossing at one point. And if we take a look at this one here, this is no x-intercept. So if we take a look at this here, it's actually, none of these graphs are actually touching the x-axis. And I will be highlighting the x-axis here. It doesn't really pass any of them go through it. So none of these here would actually be no x-intercepts. All right. Now let's go ahead and take a look at these type of problems here. So in this case, guys, it says example 1, it says a parabola intersects the x-axis at x equals -1 and x equals 5. What is the vertex? X coordinate of the parabola's vertex. So in this case, guys, they want us to find x coordinate of the parabola's vertex. In other words, they want the x coordinate of the vertex or the axis. Let me do that less. The axis of symmetry. Now, whenever you're graphing something in this case, guys, for example, this is just a random graph. You don't have to draw this. But each time you have, for example, parabola. So add a different color. So parabola. The axis of symmetry is exactly in the middle between our x-intercepts. All right. So in this case, if we take a look back at our information here, it says that the parabola intersects at x equals -1 and x equals 5. So they're actually telling us that these here represent the x-intercepts. So this one here and that one there represent our x-intercept. So in order for us to actually find the axis of symmetry, one of the ways I could do this is I could actually find the average of the x's. And finding the average of something, guys, for example, if I were to find the average age for the students in the class, I would basically be adding everybody's age and then dividing by the number of students. If I want to find the average of the x's here, I have to add both of my x's and then divide by 2 because I have two x's. So in this case, that's a -1 plus a 5 divided by a 2. -1 plus 5 is 4. 4 divided by 2 is 2. So axis of symmetry in this case is x equals 2. All right, so to find the average or to find the axis of symmetry in this case, we have to add both of the x's and then divide by 2 because we have 2 x's. All right, so let's go ahead and take a look at the next one here. And the next one says graph a parabola whose x-intercepts are at x equals -3 and x equals 5, and whose minimum value is y equals -4. Now, in this case, guys, a few things we want to go ahead and check what they're giving us is these x's here, once again, represent the x-intercepts. So if I were to graph these here, x-intercepts, those would actually be the points -3, 0 and 5, 0. So these are 2 separate points. It's not one single point, it's 2 separate points. Now, in the x-intercepts, y is always going to be equal to 0. Now, in this case, it says that we have a minimum value of y equals -4. Now, key words in this case, guys, is minimum. Whenever they're talking about the minimum, the maximum, they're actually talking about the vertex. So in this case, they're talking about the vertex, and they're talking about the y value of the vertex here is -4. So our goal in this case is to find the x-coordinate of the vertex. And if you guys remember from the previous example, the x-coordinate of the vertex is the same thing as finding the axis of symmetry. So what we actually need to find here is, once again, it could be the x-coordinate of the vertex, or it's also known as the axis of symmetry. All right. So we just saw in the previous example how to find the axis of symmetry. And for that, we need these 2 values up here. So in order for us to find the axis of symmetry, or for us to abbreviate, I'm going to just write AOS. It's going to be x equals -3 plus 5 divided by 2. -3 plus 5 is 2. 2 divided by 2 is 1. So our vertex is found at the point 1, -4. So if I were to graph this here, I'm just going to do a sketch up here. Up here. Not sure how pretty it's going to come out. So I have -1, -2, and -3. And then I have 1, 2, 4, and 5. And then I have 1, -2, -3, -4. And let me just do my labeling here. So this is x, and that's y. So my x-intercepts in this case, guys, are -3, 0, and 5, 0, which is there. And my vertex is found at the point 1, -4. So I'm going to go ahead and go 1, and then down 4. So then I'll just go ahead and draw my parabola. Now, when you guys do this in con, guys, all you need to do in this case is you're going to be dragging points. Once again, with con, there's going to be 2 separate points. The lowest point in your parabola will be representing the vertex. So that's the first thing you want to go ahead and plot. Once you plot the vertex, the other ones, you just need to move them either to the 5 or the -3, and they'll be crossing both of them. Okay, so that's it for this lesson, and let's go.